Welcome back to another Explainer. Today, we're tackling a massive and honestly often invisible problem that plagues almost every major organization out there. We're talking about transforming chaotic enterprise data into reliable, actionable intelligence. And to do this, we're going to explore a highly effective methodology known as the operator approach. So let's jump right in. Let me ask you a serious question. Do you truly trust the data driving your executive reports? I mean, really trust it? Enterprise data warehouses consolidate absolutely massive amounts of business activity, and they form the very backbone for the reports that guide critical business decisions. But what happens when millions of dollars are on the line and that underlying data is just riddled with errors? It's pretty simple, really. Bad data leads to bad decisions, period. Here is our roadmap for today. We'll start with 1, the dirty data problem, move to 2, the operator-centric approach, and 3, core data cleaning operators. Then we'll cover 4, solving record matching, 5, the deduplication task, and finally 6, building data cleaning scripts.
Okay, section 1, the dirty data problem, consolidating chaos.
Where does all this chaos actually come from? Well, errors inevitably creep in during normal data collection, sure. But the real mess? That usually happens when you start merging data that was collected completely independently across different databases. So data cleaning is defined as the continuous process of starting with raw data from one or more sources and maintaining reliable quality for your applications. The absolute most critical word here is continuous. This is not some one-time set it and forget it fix. Whether you're dealing with a data warehouse or master data management, which strives for a unified view of things like customers and products, data cleaning is a living, breathing, ongoing process.
Moving right along to section 2, the operator-centric approach, going beyond rigid systems.
Historically, organizations have really leaned on domain-specific verticals. A classic example here is Trillium, which is software tailored very specifically for cleaning addresses. Now, tools like this are great because they have deep built-in domain knowledge, but they are incredibly rigid. A tool built strictly for US addresses simply is not going to work for Indian addresses, let alone a catalog of, say, electronic products. Conversely, the operator-based approach gives us flexible, highly adaptable building blocks. It's like a giant puzzle where you can customize the pieces for literally any domain you're working in. There's this brilliant analogy from this source text that I absolutely love. If you're a database professional, this is going to click for you instantly. Just like relational algebra uses a few primitive operators, like select, project, and join, to build incredibly complex SQL queries, the operator approach to data cleaning does the exact same thing. We take a few primitive data cleaning operators and snap them together to engineer entirely custom systems from the ground up. All right, section 3, core data cleaning operators. Let's look at the actual vocabulary and building blocks of our framework. First up, we have parsing. You know how it is when you pull data from an external source, it literally never matches your target database schema. Take a messy string like this. Canon EOS Rebel T3i 1855mm IS2 kit. It's a jumble. The parsing operator systematically segments this string into structured target columns. It mathematically extracts Canon as the brand, EOS Rebel T3i as the model, 1855mm as the lens, and so on. It takes unstructured chaos and turns it into neat, highly queryable columns. Our next building block is the similarity join. In standard SQL, a join usually requires a perfectly exact match, but in the real world, data is full of typos, spelling mistakes, and wildly varying naming conventions. The similarity join operator connects records based on textual closeness instead. And this perfectly highlights the flexibility of the operator approach. You can customize the similarity function based on your specific needs. If you're comparing product parts, maybe you use edit distance to catch simple spelling errors. Or if you're comparing spoken names entered into a web form, you might use SoundX so that Robert and Rupert are actually recognized as similar. That little tweak saves Rupert's order from just disappearing into the void. The third core operator is clustering. Clustering takes a set of items and mathematically groups them together based on similarity. Consider a messy tennis dataset. We've got various spellings and formatting of player names. A clustering operator looks at the pairwise similarities between all these records and intelligently groups Rafa Nadal and Rafael Nadal into a single entity cluster, while keeping them completely separate from guys like Federer and Ferrer. It's all about bringing the right pieces together automatically. Section 4, solving record matching, the first complex sentence. Now that we have our atomic operators, parsing, similarity join, and clustering, let's see how they actually solve higher-level tasks. The crucial point here is understanding what record matching does. It's the process of identifying pairs of records across two distinct relations that represent the exact same real-world entity.
Honestly, think of it as your database's bouncer. When you import a massive new batch of customer records into your sales database, the record matching task ensures you don't accidentally let a bunch of duplicates in. It compares the incoming batch against your existing master table to find the overlapping entities, even if their names or addresses aren't typed out exactly the same way.
Next up, Section 5, the deduplication task, cleaning the master catalog. So, what if the messy data is already inside your database? Well, think of duplication as a kind of fuzzy, select, distinct operation. It groups records within a single relation that represent the same entity. But it isn't just based on simple text similarity. No, duplication is governed by rigorous, domain-specific constraints. For example, your specific business logic might dictate that a single customer should never have more than 10 replicated records in the system. Or maybe that 90% of the records in a single cluster have to share the exact same gender value. These constraints act as guardrails, powerfully guiding the clustering process to a highly accurate and reliable result. But hold on, there is a massive computational challenge here. If you have a table with millions of records, doing a pairwise comparison of every single record against every other record is, well, it's mathematically impossible to process efficiently. Your system would just grind to a halt. This is where blocking comes to the rescue. It acts as a critical pre-processing step. It's like a crude initial clustering that chunks those massive datasets down into smaller, much more manageable blocks. For instance, actually, you might block records by zip code. Then you only perform those heavy, computationally expensive deduplication comparisons on the records that fall within the exact same zip code block. It's a total game changer for processing speed. Finally, Section 6, building data cleaning scripts. This is where we assemble the system and bring it all back to the engineering level. This is where the magic really happens. When you build a custom script for record matching across two customer databases, you can see how standard relational operators and our new data cleaning operators just beautifully snap together. First, we might use standard filters to remove records with null IDs. Then we try an exact join on ID if possible. But for records without matching IDs, we route them through a string concatenation, then a segmentation or parsing operator to split up the messy address. Finally, we feed those newly cleaned columns directly into a set similarity join or SS join with a strict threshold, say 0.9. Just like that, this single visual script flow solves an incredibly complex data reconciliation problem. And for a duplication script, it brilliantly illustrates the absolute simplicity of this operator approach. To duplicate a single customer table, we literally just snap two blocks together. First, we run an SS join across all the columns with a similarity threshold of, let's say, 0.8. That immediately creates a network graph of similarities. Then, we just feed that directly into a clustering operator, which strictly applies our business constraints, like that maximum number of records allowed per cluster we talked about earlier. But remember that massive server crashing computational problem we just discussed? If that customer table has 10 million rows, that simple two-step script is going to fail. To fix this, we look to a slightly more advanced version of the script. We just pop a blocking operator right at the very top. By grouping the data by zip code and gender first, the subsequent similarity join and clustering operators only have to process tiny bite-sized chunks of data. By adding just one single operator, we dramatically improve the efficiency, making the whole thing highly viable for enterprise-scale data warehouses. So, what is the big takeaway here? Why does this fundamentally matter to your systems? Because these operators, parsing, similarity joins, clustering, blocking, they aren't just academic flowchart exercises. These customized scripts are the literal safety nets protecting the integrity of your business intelligence. They are the mechanisms operating under the hood, preventing catastrophic business reporting errors that inevitably lead to terrible executive decisions. I'm going to leave you with this final thought today. If you mapped out your own organization's data pipelines right now, how many broken links would you actually find? How much of your executive reporting is resting on unstandardized, dirty data simply because you haven't implemented a continuous operator-centric cleaning process? It is absolutely something worth looking into. Thanks so much for joining me on this explainer. Keep learning, and I'll see you next time.